Hello students, welcome back to our channel Abhyas IIT Prep. In this video, we are going to discuss about the JEE main 28th morning shift paper. Let's get into the video. So, question number 26, a 10 kg of ice at minus 10 degrees centigrade is added to 100 kg of water to lower temperature from 25 degree centigrade. Consider no heat exchange to surroundings. Determine the temperature of the water. So you have to find what is the final temperature. What is the final temperature of the water first? Then you have to find the temperature of the water. So we know that one. In this case, Q gain equal to heat gain equal to heat lost. This is our basic formula. Okay. What is our Q gain? Q gain in first process, I will tell you, at minus degree centigrade to minus 10 degree centigrade to, it will reach to at a point ice at 0 degree centigrade. Remember this one. From this one, you will increase the temperature of water. This is another state transition. From this one, if you increase the temperature at 100 degree centigrade, you will get a water vapor. Water vapor. So at this one more state transition is there. After that, you will get a water vapor here. This is your state transition to liquid to vapor. Here solid to liquid, that is solid to liquid. Remember this one, we are having one question on this. So see here, for a state change you have to use ML, that is a latent heat of a fusion or a latent heat of latent heat of fusion or latent heat of water, specific heat. So see here, Q gain equal to, I am writing Q gain. First one, heat taken by the ice, that is MS delta T. MS delta T. Take this ice, specific heat of ice, plus change, state change, that is ML latent heat of fusion, plus MS delta T. This is for water. Okay. Next one, that lost is equal to MS delta T, weight of water and specific heat of water and delta T. This is your equation. What do you have to do? You have to just substitute the values. Mass of ice is 10 kg into specific heat of ice 2100 kilojoule, joule per kilo. And what is the delta T? Initial temperature minus final temperature. Final temperature minus initial temperature. T final minus T initial. T final 0 minus of minus 10 degree centigrade minus of minus 10 plus mass of the ice, that is also 10, into latent heat of fusion, that is 3.36 into 10 to the power 5 plus mass of the ice 10 into specific heat of water 4200 joule per kg. What is the delta T? Delta T can be written as a final temperature minus, what is the temperature here? That is 25. Initial temperature to second case. This is equal to mass of the water. We have given to mass of the water, that is 100 kg into specific heat of water 4200 into and delta T. have to take what is the delta T? Cut. Okay, see here, delta T, that is nothing but 25 minus T fine. If you find the and cancel the terms, you will get a final temperature is 15 degrees centigrade. This is your final temperature. But what is the lower temperature? You have to find the change in temperature. Discrement to the temperature of the water. What is that one? 25. So delta T can be written as mod of 15 minus 25. You will get 15 degrees centigrade. Option 2 is your answer. This is a little bit lengthy. Just remember this one. This graph you have to remember. Okay. Next one. The electric current in the electric circuit given as I, they have given the RMS current for the period T equal to 0 to capital T. RMS. So see, I RMS can be written as RMS square can be written as integral 0 to T. What is I square? I am writing I square. I naught square T square by capital T square into dt by integral 0 to T dt. This is our I RMS. So if substitute the values and derive that one, I naught square by T square by, we are having one T integral, if T square, that is nothing but a T cube by 3. See here, I naught square by T square T cube by 3 by T. Okay. If we cancel out, you will cancel it. Okay. So I RMS can be written as I naught by root 3. I RMS can be written as I naught by root 3. So option 4 is your answer. Next question, question number 28. In a potentiometer, when the cell in a secondary circuit is shunted with 4 resistance and the balance is obtained at length 120 centimeters. Take this length L1 and resistance R of wire. Now when the same cell is shunted, you have one more resistor R2 and balanced at length 180 centimeter. This is L2, the internal resistance of the cell. What is the formula for internal resistance? We know that formula, L1 by L2 equal to capital R by small r plus capital R. Okay. See here, in first case, case 1, L1, what is that one? 120 centimeter, take it as L0 equal to R 4 ohm by R plus 4. If you rewrite this one, you will get 120 into R plus 4 equal to 4 L0. Take this equation 1. For second case, case 2. What is this one? 180 by L2 equal to, what is the resistance? 180, 12 ohm resistance by R plus 12. If you write this one, 180 into R plus 12 by equal to 12 into L0. 12 into L0. So 1 by 2. If you cancel the and rearrange the things, you will get the answer r equal to 4. This is your answer, r equal to 4. Next, 29. Two circular discs of radius, they have given radius, okay, are joined at their center by rod of length 30 centimeter and mass 60 grams. One more rod is there, mass they have given and the length they have given as shown in figure. If the mass of each disc is 600 grams and applied torque between the two discs, they have given torque. The angular acceleration of a disc about the given axis is. So see, acceleration can be written as torque tau by I. What is the primary task? You have to find the moment of inertia. Moment of inertia. If you assume this 10 is r, this 10 is r, then this is also r, 10r, this is 2r, okay, in terms of r, this is also r. One more is there, if you find the distance, total distance, total length of the wire, total length is 30 centimeters. What is the L by 2? L by 2 is nothing but 15 centimeters. What is the midpoint for this 10? So it can be 15 minus 10, you will get 5 centimeters. This is our D. D can be written as R by 2. D can be written as R by 2. First to remember those things. For circular disc, as a parallel axis theorem, I parallel can be written as mr square by 4 plus md square. We are having two discs and R is different for two things. R is different, so R is also same. R is also same. Then D is different. D is different. So D can be written as R by 2. Next, see here. For this is for disc. For a rod, rod can be written as I parallel ml square by 12 into md square into md square. So I net can be written as I disc plus I rod. See here, what is the D? That is nothing but R. For first case, first I am writing for this one, first disc I equal to mr square by 4 plus m D. What is D? Distance, that is nothing but R square plus one more disc mr square by 4 plus what is the distance? 2r. So mr square, that is nothing but 2r square plus, now I am writing for a rod. What is rod? M L square. What is L? L is nothing but 30. What is L? Length equal to 30 centimeters. You can write 3r. Why I am writing in terms of r? You can simply cancel out. So 3r whole square by 4 plus md square, that is r by 2, m r by 2 whole square. Okay. If you find the moment of inertia, you will get the answer. If you find the moment of inertia for this one, you will get I equal to, you will get I equal to 39 into 10 to the power 4, and we are having torque 43 into 10 to the power 5. If you cancel out these things, alpha is nearly equal to 11 radian per second square. This is your answer. So option 2 is your answer. Question number 30. Water drops fall from the tap on the floor. This is our water tap. Okay. Water drops are falling from the floor of height 5 meter. Of height 5 meter. At a regular interval of time, the first strike the floor when the sixth drop begins to fall. Okay. The height at which the fourth drop will be from the ground. So per second, how much drops we are getting? Per second, we are getting 5 drops. Per second, we are getting 5 drops. From the question, per second, we are getting 5 drops. What is the time for one drop? Is nothing but 0.2 seconds. 0.2 seconds. How to find how many per second we are getting drops? Time to reach ground is nothing but under root h by, so g by 2h. So that is nothing but 10 by 10. You will get 1 second. You will get 1 second. Per second we are getting 5 drops. For one drop, you should have 0.2 seconds. 0.2 seconds. What is about fourth drop? How much time it will take? Here, first drop, second drop, third drop, and a fourth drop. This is 0.2 seconds, 0.2 seconds, 0.2 seconds. So after 0.6 seconds, the fourth drop will drop from the tap. So what is the time? Time taken to reach the ground. How much time? 1 minus 0.6 second, that is nothing but 0.4 second. So height h can be written as ut plus half at square. What is a? That is 10. What is t? 0.4 second t square. If you solve this one, 5, that is 10 whole square 16, that is you will get a 0. Just wait, 0.16, and that is 1.6 by 2. You will get 0.8 meter. 0.8 meter. This is your height. So what is the actual height? That is a 5 meter. If you subtract the 5 minus 0.8, that is nothing but 4.2 meter. 4.2 meter. This is your, at that instant, first drop strike the ground. So height is nothing but 4.2 meter. Next question. See, an atom X they have given. 8.3 is bounded by shower of fundamental particles in a 10 seconds. This atom absorbed by 10 electrons and 10 protons and 10 neutrons. The percentage growth error in the surface area of the nucleus. Surface area is directly proportional to a to the power 2 by 3. In case of first, initial surface area equal to 8 to the power 2 by 3. 8 to the power 2 by 3. So this can be written as 4K. This can be written as 4K. What is about final surface energy? So 8 plus 9 plus 10 to the power 2 by 3, you will get a 9k. Okay, percentage error in surface area of nucleus is recorded. So percentage error can be written as 9k minus 4k by 4k into 100 percentage into 100, you will get a 125 percentage. That is your percentage growth in particle atom. So next question, see here 32. The electric field of electromagnetic wave, they have given electric field in the refractive index of the medium. Then you have to find the refractive index. Refractive index can be written as C by V. So if V by C can be mu. How to find V? V can be written as omega by K. If you see what is the omega? Omega T. That is nothing but 2 into 10 to the power 15 by what is the K? 10 to the power 7. If you cancel out, you will get 2 into 10 to the power, what is the 7? 8. If you observe here, you will get 2. Okay, see here. 3 into 10 to the power 8 by 1.5 must be equal to C by mu. So what is the value of mu? Mu can be written as 1.5. Mu can be written as 1.5. Option 3 is your answer. See this one. Earlier, which of the following best representation of temperature versus heat supplied to the graph for water in the range of minus 20 degrees to 120 degrees? Which is, this is not. Earlier we have discussed this. So see here, from here to here, from minus degree centigrade to 0 degrees, you will get ice here. Okay, from ice 0 degrees to and water at 0 degrees centigrade, you will get here. And after this one, if you raise the temperature 100 degrees centigrade, you will get water to water vapor at 100 degrees centigrade. After that, if you again increase the temperature at 120 degrees, you are having water vapor. That is option 2 is your correct answer. 34. 3 long straight wires carrying current arranged mutually parallel as shown in figure. The force experienced by 50 centimeter length of wire Q, which is having 15 centimeters. So force can be written as mu naught I naught by 2 pi. Okay, I1 by L1 plus I2 by L2 into L0. L0 and I0 belongs to the Q conductor. So see here, mu naught 4 pi into 10 to the power minus 7 into I0. What is the I? Through the Q, that is 1 by 2 pi. Pi gets cancelled and 2 gets 2 times. What is I1? 3. So 3 by 3 plus I2 2a by 2 into L0, that is 15 centimeters. You have to convert that into meters by, I am writing 10 to the power minus 2 because these two are in centimeters. So see here, 1, this is 1, this is 1, 1 plus 1, 2. That is 1 plus 1 is 2. One more 2 is there. 2 2s are 4 and 2 2s are 4. So 4 into 15. 15 into 10 to the power minus 7. 10 to the power minus 7. If you rearrange the things, you will get that is 6 into 10 to the power minus 6. This is your force. Newton towards there. Why towards there? It is in same direction. That's why these two are attracts. Okay. Next question. Question number 35. Assuming in forward bias condition, there is a voltage drop 0.7 volts across the silicon diode. The current through the diode 1 in the circuit, milliamperes, you have to find in milliamperes. So diode 1 is forward bias, this is working. Diode D2, that is in a reverse bias, that is not working. First you have to check this thing. Next one, diode 3 is also working. So the voltage is divided equally by D1 and D3. D1 and D3. What is current? What is current? Current can be written as I equal to total voltage minus 0.3 kilo ohms. Sorry. Total voltage minus diode voltage, that is 0.7 volts by 0.3 kilo ohm equal to, that is 11.3 by 300. How much you will get? You will get around 36.6 or something. This is our voltage. Voltage through D1 only. What is that one? Voltage through. This is our milliampere current. So voltage through. So current through the D1. Sorry, not voltage. D1. Current through the D1. So I D1 can be written as 36.6 by 2 milliamperes. You will get around 18.8 or something like this one. Option 4 is your answer. Milliamperes. Question number 36. The magnitude of a power of a biconvex lens. Biconvex lens. This is our biconvex lens of refractive index of 1.5 and that plano concave lens, okay, of refractive index of 1.7. If the curvature of a plano concave lens is exactly matched with the curvature of the back surface of the biconvex lens, if this is R2, this will be R2, and what is this radius of curvature? That is infinity. Take this one as R1. Okay, then the ratio of radius of curvature front and back the surface of the biconvex lens, you have to take the R1 by R2. R1 by R2. You have to find R1 by R2 value. What they have given? Magnitude of biconvex lens power equal to magnitude of plano concave lens. This is our condition. What is that power? Power can be written as mu minus 1 into 1 by R1 minus 1 by R2. So see here, mu minus 1 by convex lens, that is from this one you can write as 0.5 into 1 by R1 minus 1 by R2 equal to 1.7, you can write 0.7 by R2. If you find R1 by R2 from this equation, you will get 5 by 2. Option 1 is your answer. Question number 37. In the following pressure and volume diagram, the equation of a state along the curved path is given by 4 AP, where A is constant, the total work done in closed path. P is nothing but pressure and V is nothing but volume. So see, what is this distance? From 1 to 3, you will get 2. Take this point as a P. Okay. You have to find the, for work done, area under the curve. for work done, area under the curve. Work done can be written as area under the curve. Area under the curve. I am writing area under the curve. So W can be written as 2 by 3 times of the area of a triangle. See here, area under the curve, this is our parabola. Parabola. So parabola can be written as area of a triangle. Take this one. Take this point A and a point 1 and a point 3. This is our triangle. This is our triangle. So area of a triangle. So 2 by 3 into height, that is a P, into what is base, that is 2. We find 4P by 3. This is our work done. If you see that condition, equation they have given, from equation take volume equal to 1 minus 2 whole square can be written as a 4AP. From this one you have to find P equal to 1 by 4A. 1 by 4A. So if you substitute here 4 by 3 to 1 by 4A, 4 gets cancelled, 1 by 3A. So which is in a reverse direction. So which is in anti-clockwise direction, you have to take a negative. So from this one, option 4 is your answer. Question number 38. For two cells having same EMF E and internal resistance R, the current passing through the external resistance is 6 ohm is the same when the both cells are connected either parallel or in series, then value of the internal resistance. So we know that one. For series combination, I series can be written as NE by NR plus capital R. For I parallel, you can write I parallel E by R by N plus capital R. This is our condition. This is our formulas. What is the condition they have given? They have given the I parallel equal to I series. I parallel equal to I series. I parallel, I am writing E by R by N. What is N? 2 plus a capital R, that is 6 ohm, that is 2E by 2R plus a 6. If we cancel out E and E, okay, next one, if you rearrange the things and find the R, you will get as R equal to 6 ohms. R equal to 6 ohms. Correct option is 4. 39. Two wires A and B made up of two different materials of length 6 centimeters and 5.4 centimeters respectively. The area of cross section, they have given two cross sections respectively, are stretched by the same magnitude under a given load. Then the ratio of modulus of YA by YB. YA by YB. So we know that one. Young's modulus can be written as F by A into L by delta L. So Y is directly proportional to L by A. You have to find what you have to find? YA by YB. YA L1 or LA. See here I am writing LA by LB into AB by AA. LA, what is this one? 6 centimeters by 4.5 centimeters into A2, that is AB 4.5 into 10 to the power minus 5 by 3 into 10 to the power minus 5. Cancel out the things. What is this one? What is this one? 5.4. That is 5.4. Okay, see. This is 2. 9 by 5.4. If you see this one, you will get a answer as a 5. You will get answer as a 5. So that is nothing but x equal to 5 is to 3. So x value can be written as 5. Next one. a block of mass 5 kg is moving on an inclined plane which makes an angle of 30 degrees. So take this one, inclined plane. Plane is having 30 degrees and a block is moving upward. This is our F, force direction. We know that. After that I will write. Friction coefficient between the block and inclined plane surface. So mu they have given. Mu is nothing but root 3 by 2. The force to be applied on the block so that block will move down without acceleration. So without acceleration means F net can be 0. F net can be 0. So what is that? F net can be 0. That is the equilibrium position. So see here, downward you will get mg sine theta. At this point you will get mg cos theta. Upward you will get a normal force, that is N. We know that one. Back side you will get one frictional force F. F is nothing but mu N. F is nothing but mu N. What is N? N is nothing but mg plus sine theta. One more force is there. So at equilibrium position, mg sine theta equal to mu N, that is nothing but mg cos theta plus F. I want to find F. So I am writing here M. What is M? M is 5 kg. G they have not mentioned. That's why I am taking 10. See here. I have to bring mu mg this side. So 5 into 10 sine 30. 1 by 2 minus root 3 by 2 into m 5 into 10 into root 3 by 2. So if you subtract and calculate these things, you will get the value as 12.5 newtons. That is your force. Next one, the given statements they have given. A plane wave after passing through the prism remains as a plane wave, but passing through the small pinhole may become a spherical wave. What is that? Is that true or not? So statement 2, the curvature of the spherical wave emerging from a slit with the increasing in slit width. What is this one? Passing through the pinhole. Passing through the pinhole, we are having plane waves. In case of prism, if we are sending plane waves, it will totally refracted. What in case of a pinhole, that is a slit? This can be diffracted and acts like a point source. So statement 1 is false. Okay. Second statement, the curvature of a spherical wave emerging from slit with increasing slit width. So angle of diffraction can be written as theta equal to lambda by A. A is nothing but slit width. So if you are increasing diffraction, so if you are increasing or decreasing the diffraction, it will increase the diffraction. So the question is say statement 2 is false. Statement 2 is false. Okay. So if a slit is increasing, the sphericalness will decrease. If a slit is decreased, the sphericalness will increase. That is the question. So statement option 4 is your answer. Question number 42. When two jaws of vernier calipers touch each other, 0 mark of the vernier scale is 2. 0 mark of the main scale, that is the 4. They have given the error with coincide with a certain mark on the main scale, while the measuring of a length of the cylinder the observer observes the 15 division on main scale and 5th division on vernier scale coincide with the main scale division, measure the length of the cylinder. So reading, total reading can be written as total reading MSR plus VSR vernier caliper reading into least count minus error. I am writing from here. What is main scale reading? That is 5. So 5 millimeters plus what is vernier scale reading? 15 plus vernier scale reading, that is 5 into least count 0.1 minus error. They have given a 4th mark, so 4 into 0.1 millimeter. Okay. So 0. Here you will get a 0.4. Here you will get a 0.5. If you subtract, you will get a 15.1 millimeter. This is your final answer. Option number 2. So next question number 43. The magnetic field at the center of the current carrying circular loop of radius r is 16 microtesla. The magnetic field at a distance x equal to under root r on its axis from the center is. So what is the condition here? Magnetic field at center can be written as a mu naught I by 2r, that is nothing but they have given 16 microtesla. Magnetic field at the distance x, so magnetic field at the distance x, you can write it as a mu naught I r square by 2 into r square plus x square whole to the power 3 by 2. Okay, what is the x here? Mu naught I r square by 2 root 3r, so 3r square plus r square whole to the power 3 by 2. You will get here, what you are getting? I am writing here, see here, mu naught I r square by 2 into 4r square into 2r. If you see here, observe, mu naught I by 2r, this is nothing but 16 microtesla. So 4r and r square gets 16 microtesla by 8. So this can be 2 microtesla. Option 3 is your answer. Next question 44. 2-point charges 1 nanocoulomb and 2 nanocoulomb are placed at the 2 corners of the equilateral triangle of side 3 centimeters. The work done in bringing the charge of 3 nanocentimeter from the infinity to third corner of the triangle L is. So assume we are having a triangle, 1 nanocoulomb, 2 nanocoulomb. We have to bring 3 nanocoulomb to position 3. How much work done you have to complete? So work done can be written as K Q1 Q2. So assume this is a Q3. Assume that is Q3. This is a Q3 by L plus K Q2 Q3 by L. Okay, I am taking common K. K can be written as 9 into 10 to the power 9. L, what is L? Length 3 centimeters, that is nothing but 3 into 10 to the power minus 2. Q1, I am taking out Q3 also common. What is this one? 3 into 10 to the power minus 9. and q1 plus q2. What is q1? That is 1 10 to the power minus 9 plus 2 into 10 to the power minus 9. 3 and 3. Okay. 10 to the power 9 and 10 to the power 9. Here you are having 3 into 9, that is 27. 27 into 10 to the power minus 9. If you cancel these two, you will get minus 7. You will get minus 7. If you convert that into microjoules, 2.7 into microjoule. Option 1 is your answer. Next, question number 45. A particle of mass m falls from the rest through the resistive medium having resistive force F. So take this. This is our particle which is falling under gravity mg, and one more is there. At this particle we are having one drag force, that is F equal to minus kV, which is moving in downward. V is the velocity of the particle and k is the constant. Which of the following graph represent the velocity versus time? For this diagram, you have to write F can be written as mg minus kV. So we are having V, that's why I am taking mass into dV by dt, that is nothing but mg minus kV. Because I am having velocity, that's why I am taking acceleration in terms of V. So integral 0 to V dV equal to mg minus kV equal to integral 0 to t m dt, 1 by m dt. From this one, if you multiply with minus 1 by k and multiply with k minus k, you can cancel out these two. Why we are taking this one? Okay, why we are taking this one? From this one, you will get ln minus 1 by k ln mg minus kV by mg, which is equal to, I will write after some time, which is equal to Tm, which is equal to Tm. I am writing here ln 1 minus kV by mg minus kt by m. So from this one, you can simply write V equal to e to the power minus kt by m. Here you are having minus, that's why this will be minus e1. Okay. Next, mg by k. This is our velocity equation. If these two negatives, you will get a decreasing exponentially. So velocity is decreasing exponentially. So next, option 4 is your answer. Option 4 is your answer. Next, section B. The displacement of particle executing simple harmonic motion with a time period t executing as, that is sine wave. So where A is the amplitude and maximum value of the potential energy of this oscillator at t equal to 2 by beta, then the value of beta. So maximum value of potential energy. So if you see here a simple harmonic motion, take this one bob. If you extreme position, you are getting, what you are getting? You are getting maximum value of potential energy. Maximum potential energy you are getting at this position. So how much time is taking? If a total time period is t, so total time period is t, how much time it will take to oscillate? So from mean position to extreme position, it will take t by 4 time. it will take T by 4. So you have to equate these two equations, that is T by 4 equal to T by 2 beta. T gets cancelled, this is 2, so beta can be 2. Next question. The ratio of de Broglie wavelength of a deuteron and kinetic energy E to the alpha particle with kinetic energy 2E is n is to 1, then the value of 1, n. So we know that one de Broglie wavelength can be written as lambda equal to h by under root 2mk. K is nothing but kinetic energy. What is m? Mass of alpha particle 4 times of mass of proton, and mass of deuteron is nothing but 2 times of mass of proton. This is our condition. So lambda is inversely proportional to lambda deuteron, ratio of lambda of deuteron by lambda of alpha particle can be written as m alpha k alpha by md kd under root. Mass of alpha, that is 4 k alpha. K alpha is nothing but 2e by 2mp into E. E gets cancelled, mass of proton, and 2 gets cancelled, you will get 2. 2 is to 1, that is 2 is to 1, n value is nothing but 2. Next, 48. A solid sphere of radius 10 cm is rotating about an axis which is at a distance rotating about an axis x, okay, at a distance 15 centimeters from its center, 15 centimeters from its center. So it is rotating about an axis which is 15 centimeters from the center. Then the radius of gyration about its axis root n, then the value of n. Radius of gyration, that is I equal to mk square. What is the I parallel in case of solid sphere? 2 by 5 mr square, 2 by 5 mr square, md square, md square. So equate these two. From here, mk square equal to 2 by mr square by 5 plus md square, md square, gets cancelled, okay. K square equal to 2 into r square, that is 10 100 by 5 plus d square, that is 15 square, you will get a 225. You will get a 225. Total you are having 245. Sorry, 265. 265. What is K? K is nothing but under root 265. So n can be written as 265. Next, question number 49. A concave lens of refractive index 1.5 and the focal length they have given is immersed in water. The difference in a focal length of a given lens when it is in water and it is in air. It is in air. So focal length of a lens which is in air can be written as 1.5 minus 1 by 1 into 1 by R1 minus 1 by R2. Focal length in water can be written as 1.5 minus 4 by 3 by 4 by 3. 1 by R1 minus 1 by R2. What do you have to find? You have to find the ratio. So F water focal length in water can be written as F into air, that is they have given already, that into water. You have to take 0.5 by 0.5 by 4 by 3. Take that 18 centimeter and substitute here. You will get 2 centimeters. Sorry, you will get 3 centimeters. What is the focal length in water of that length? That is 3 centimeters. Next question, see here. Question number 50. The equivalent resistance between the point A and B following circuit is X by 5 ohm. Then the value of X. See here. If you can assume it is a Wheatstone bridge 6 by 3, that is 2 by 1, and 3 by 6, which is not possible. This is not Wheatstone bridge. How to solve this one? I will tell you. So rearrange this diagram from there. 6 ohm from A, you are having 6 ohm resistor. From volt 1, we are getting current I. In 2 ohms, it is sharing. Okay. From, take this point C and point D. From point C, it is assuming one more current 2I1 minus I, which is having resistance 3. And from C also, C to B, we are getting current I minus I1. Okay. For this process, see this one. For this loop, 6I1 plus 3 into here 3 into 2I1 minus 1 minus I equal to 3 times of the I minus I1. So this is from here, from C to B and a voltage. So sum of volts equal to 0. I hope you know this one. So from this one you can simply find at 3, from this one you can find I1 equal to 2 by 5 I. For this loop 3 is there, 3 into I minus I1 plus 6 into I1, that equal to 1. So from this one you will get 3 plus 6 by 5 I equal to 1. So if you solve this one, you will get I equal to 2 by 21 amperes. If you find R equal to, you will get 21 by 5. So what is the value of X? X can be written as 21 ohm. X value is 21 ohm. So this is our end of this session. So thanks for watching. If you are having any doubts, please comment below. Thank you.